Okay, so on this one, what we're being asked to do is we're being asked to find the unit vector. So the way we find the unit vector is we take the vector and we divide it by its magnitude. So basically on this, we need to find the magnitude first, and then we're going to divide each of the x component and the y component by the magnitude. So for number one, this is going to be u1 and this is going to be u2. So when we find the magnitude, we're going to take the u1 squared plus u2 squared. So we're going to plug those values in. So we're going to have the square root of 6 squared plus 0 squared. So 6 squared is 36 plus 0. So we get the square root of 36, which simplifies to 6. So if we want to find the unit vector, we're going to take each of the components of our vector, and we're going to divide them by the magnitude, which we found was 6. So I'm going to take the 6 and the 0 and put those in the numerator. So then all we got to do is to simplify the expressions. 6 divided by 6 is 1. 0 divided by 6 is 0. So our unit vector has a x component of 1, y component of 0. Okay, for number 2, we are finding the unit vector again. So this one also is given in component form, just like number 1. So here we're given u1, u2. So we need to find the magnitude of vector v first. So the way that we do that is we take the square root of the x component squared plus our y component squared. We're basically following this exact same formula, it's just now we're using the letter v, which nothing else changes. So we have negative 1 squared plus negative 1 squared, and we're going to take the square root of all that. So negative 1 squared is 1. Negative 1 squared again is 1. So we get the square root of 2. Okay, so just like the last one, we are going to now take our x component and our y component. And when we find the unit vector, we're going to take each of those components and divide it by our magnitude. Which is square root of 2. So on these, we end up with a square root in the denominator, so we do need to rationalize. So I'm going to leave a little bit of space. So we're going to need to basically multiply by the square root that's in the denominator, in the numerator, and in the denominator. And we're going to do that to both components. So when we multiply square roots, we multiply the outside by outside, inside by inside. So in the top, we have negative 1 times the square root of 2, which is negative square root of 2. And square root of 2 times square root of 2 is the square root of 4, which simplifies to 2. Same thing over here. Notice the numbers are exactly the same, so it's going to end up being exactly the same numbers. So our component form is negative square root of 2 over 2, negative square root of 2 over 2. Okay, so the only thing that's different about number 3 is the fact that it has the vector given in standard form. So if you need to, you can convert it to component form by basically just looking at the coefficients. So the coefficients are the numbers in front of I and j. So the coefficient of I is our x component, which is 4. And the coefficient of j, which is negative 3, is our y component. So this is v1, v2. So now essentially everything is just like the previous two problems. So we need to find the magnitude first, and then we're going to take each component and divide it by its magnitude. So we're going to take the x component, which is 4, and square it. we're going to take the y component, which is negative 3, and square it, add them together, and take the square root of all of it. So the square root, the 4 squared is 16. Negative 3 squared is positive 9. We add those together, we get the square root of 25. And the square root of 25 will simplify as 5. So now when we find the unit vector, we're going to take each of our components, 4 and negative 3, and we're going to divide them by the magnitude, which is 5. Now on this one, if we could simplify this, the fractions, we would, but these are actually already simplified for us, so this is our answer. Alright, so on these we're being asked to find the magnitude, which is given by this symbol, and we're being asked to find the angle, which is given by theta. So if we look at the trig form, the magnitude is basically the number in front of the parentheses. The angle is given by theta, so it's after sine and cosine. So on number 4, when we're asked to find the magnitude, all we got to do is look at the number that's in front of the parentheses. So our magnitude here is 5. Then to find the angle, we just look at the only angle that's there. And that angle will always be the same. In this case, it's 30. Now number 5 is going to be worked the same way. So we're going to find the magnitude first, which we'd find by looking at what's in front of the parentheses. And then our angle theta is the only angle that's there. Okay, so on these what we're doing is we are finding the component form of these vectors, and we're going to be given the magnitude and the angle. So the only thing that we can do is to use the trigonometric form. So the formula's down here. So we're basically going to plug those values in to the trig form. So for number 6, oops, this one's vector u. So the vector is going to be equal to its magnitude, which is 3, times the cosine of the angle, which is 45, I plus sine of the angle, 45, j. So all we did is we plugged this and this into this equation. So the next thing that we want to do is we're trying to get this down to component form, which looks like b1, b2, or u in this case. So we got to use our unit circle so that we can replace the sine and cosine values to get rid of those trig equations. Okay, so we're going to replace the cosine with the x value at 45 degrees and the sine with the y value at 45 degrees. So if we look at 45 degrees, this is where our cosine value is, and this is going to be our sine value. So the cosine is square root of 2 over 2, and the sine is also the square root of 2 over 2. So that's where we're going to replace these with. So keep everything else the same. And we're going to replace the sine and cosine with the square root of 2 over 2, because that's the x value there. And square root of 2 over 2 is the y value at 45. So now from here we want to distribute out the 3 because we're trying to get this in component form. So this is like saying 3 over 1. So we have 3 square roots of 2 over 2 I plus 3 square roots of 2 over 2 j. Now when we convert this to component form, all we got to do is to look at the coefficients of I and j. So we look at our coefficient, and those are our two components. our answer would have an x component of 3 squared root of 2 over 2, and a y component of 3 squared root of 2 over 2. Okay, now number 7, we're going to work just like we did number 6. So put a line, separate it. So this time we're talking about vector w, but nothing else changes. It's just a different letter. So we're going to take our magnitude and we're going to place it in front of the parentheses. So that's 7 over 2. And then we're going to multiply that by the cosine of the angle, which is 150. I plus sine of the angle, 150. J. So we want to get this down to component form, which looks like this. So we need to get rid of the I and the J. But before we can do that, we got to get rid of our trig functions here. So we're going to get rid of those by looking at the x value for cosine. And for sine, we're going to be looking at the y value at 150. So if we go to 150 degrees, the x value is negative square root of 3 over 2. And the y value is 1/2. Now everything else I'm just going to bring down. So that's 7/2, the parentheses, the plus, I, and the j. Everything else just got brought down. Now what we want to do is we need to get rid of this parentheses by taking the 7/2 and distributing. So we multiply outside by outside, inside by inside. 7 times the negative square root of 3 is negative 7 square root of 3. 2 times 2 is 4. So we're going to do the same thing here. 7 times 1 is 7. 2 times 2 is 4. And we keep the j. So when we convert it to component form, we're looking at the coefficients. So that's in front of I, in front of j. So negative 7 square root of 3 over 4 is the x component, and the y component is 7 over 4.